Today we are going to discuss about Le-Chatelier's principle. What does Le-Chatelier principle do, or what does Le-Chatelier principle states? It states that when a change is imposed to a system at equilibrium, the system will act itself to nullify the change and retains the equilibrium. That is, whenever you make a change to a system at equilibrium, it will act back to retains the equilibrium. And the changes can be changes made in concentration, pressure, temperature. Now let's look to the reaction in which N2 plus 3H2 give 2NH3. We know that it is Haber's process, and in Haber's process delta H is equal to minus 92 kilojoules, and so that the heat is produced as like a product. It is a exothermic reaction. Now we are going to change the pressure, concentration and temperature of this equilibrium or this system. So for that first of all I am going to make change in the concentration of this reaction. So first we are going to add more N2 to the system. Adding more N2 means we are increasing the concentration of the reactant. So the system will try to reduce the concentration of the reactant. For that, more reactants are converted to product. That is, the system will increase the rate of forward reaction. So adding more N2 will increase the forward reaction. That is, more NH3 is produced. As like adding N2, adding H2 also make a similar change. That is, we are increasing the concentration of reactant. So the system will try to decrease the concentration of reactant. For that, more reactants are converted to product. That is rate of forward reaction increases. Next, I am going to reduce the concentration of NH3. That is, we reduce the concentration of product. So the system will try to increase the concentration of product. For that, forward reaction increases. We know that when the product decreases, the system will try to increase the product. For that, more reactants are again converted to product. So it will increase the rate of forward reaction. Next, I am going to add some NH3 to the system. That is, I am increasing the concentration of product. Increasing the concentration of product, the system will try to decrease the concentration of product. For that, more NH3 is converted back to N2 and 3H2. So the system will increase the rate of backward reaction. That is, to reduce the concentration of NH3, the system will increase the backward reaction, and more NH3 is converted back to N2 and H2. Next, we are going to make a change in pressure. Pressure is always connected with number of moles. That is, when the number of moles are high, it means the pressure is high. Now let's look how number of moles is associated with the pressure. Let's imagine two boxes of same volume like A and B. In box A, I put 1, 2, 3, 4, 5 balls, and in box B, I put 2 balls. Here, In box A, the total volume is divided up to equally among the 5 balls. So each of these balls have a restricted amount of volume. So the pressure is high. These 5 balls have less space to move. And in box B, it has more space. That is, the total space is divided between only 2 balls. So each of the balls have more space to move. So in box A, it will be high pressure, and in box B, it will be low pressure. Now we are going to change the pressure of the system. Let's look the number of moles in the reactant side and product side. In product side, we have 2 moles, and in reactant side we have 3H2 plus 1N2, that is 1 plus 3, we have 4 moles. So increasing the pressure means we are favoring the reactant side, and decreasing the pressure means we are favoring the product side. So I am going to increase the pressure, means I am favoring the product side, reactant side. So the system will try to favor the product side, which is of low pressure. So the forward reaction increases. So increasing the pressure will favor or increase the rate of forward reaction here. That is, I am going to decrease the pressure. Decrease in pressure means it favors the side of product. So the system will try to favor the reactant side. That is, backward reaction increases. When we decrease the pressure, the system will try to increase the pressure. That is, to increase the number of moles, the system will increase the rate of backward reaction. So decrease in the pressure increases the backward reaction. Next, we are going to change temperature of the system. Here, heat is produced in this reaction. So let heat be here. Now I am going to increase the temperature. That is, we are adding more heat to the system. So the system will try to decrease the heat. To decrease the heat, it will move to the reactant side. So the system will increase rate of backward reaction. On increasing the temperature, the system will increase the rate of backward reaction. Now I am going to decrease the temperature. Decreasing temperature means the system will try to increase the temperature. So that increase in temperature is with product side. So the system will move to product side. That is, rate of forward reaction increases. That is how Lake Chatelier principle is explained.